What I have here is an ear that's been infected with gibberella ear rot. And you can see at the tip of this ear, it's kind of a whitish, pinkish type mold that starts at the tip and works its way down. Once in a while in the field you can see this where, depending on the different hybrid that you're working with, it can start at the base and work its way up a little bit, but that's just on certain hybrids, and most of those are hybrids that kind of dry down with the ear in the upright position. Most of the time though, when we're scouting fields, when we see this, it's at the tip of the ear, and that's definitely the most prevalent. Why the tip? This fungus enters the ears through the silks. Okay? These spores are basically hitchhikers. Okay? They jump on that pollen and ride that into the ovaries, and that's where they affect they develop, and that's where they produce the mycotoxins within that ear. Okay? So when you have weather out there in the summertime during silking, weather that favors silk elongation and pollen shed, that's also weather that favors the spore development and infection of these ears. So how do we manage it? Really, there's three management things that we're going to talk about here today. The first one is hybrid selection, and by far, if you can find some hybrids that are resistant or offer some resistance to gibberella ear rot, that's definitely going to be your best option. The problem is there's not a whole lot of that, and sometimes getting that data from your seed companies can be kind of tough. The other option is crop rotation and residue management. The problem with crop rotation is the same fungus that affects the corn in the ear rot also affects soybean seedling disease and gives us those seedling diseases. It also affects wheat in terms of head scab. And then in corn we have the ear rot and the stalk rot. So rotating to a different crop really is not going to resolve that issue. As that crop dies and that residue is right there on the soil surface, in the absence of tillage, there's no way to destroy that residue, and those spores are just hanging out there on the top of the soil waiting for the next crop the following year. So that's why this one may not work as well. Another option that we have is the use of fungicides. In most of the research trials, fungicide use has been highly variable. And the main reason for that is just because of some equipment limitations. If you think about it, if you have to go in and spray a fungicide, around silking time when that plant's, tasseling, that's some pretty tall corn to drive through, okay? So not only are you driving through tall corn, but you have to get that fungicide down around the ear on that plant. So you have to have some sort of drops or some kind of way of getting that fungicide to the right part of that plant. So as you're driving through there, you've got drops on. If you're on a nice level field, that's one thing. But if you're in a field that has some rolling terrain or some of the hillsides like we have in Knox County, that can be pretty tough. And I think that those application issues are why we're seeing some trouble with fungicides not being as consistent for control. What if we had weather data that we could use to predict vomitoxin levels in your corn? Right now, for those of you guys who grow wheat, you're probably familiar with the head scab model that Dr. Pierce Paula, our plant pathologist at Worcester, came up with. That does a pretty good job of predicting head scab levels by looking at existing weather data. Currently, he's trying to work on the same sort of model to predict vomitoxin levels in corn. Basically what he's looking at is rainfall, temperature data, surface wetness, those types of things on corn plants, basically at silking, and 5 days on either side of silking, 10 days on either side of silking, or 15 days on either side of silking. And what he's come up with, a model that he's currently working on, it looks like that period 7 to 21 days after silking seems to be the most critical period. And within that time frame, you're looking at temperatures between 59 and 68 degrees and relative humidity over 80%. Okay, and how many hours each day those plants are affected to those conditions. And with that model, he's been able to predict vomitoxin levels within 1 part per million with 80% accuracy. Now think about that for a minute. If you can predict based on weather patterns with an 80% accuracy or better, the chance of you having vomitoxin in your corn this year, I think that's something that we'd all like to have. Whether we're a grain farmer, whether we're a livestock farmer, those would give us some options to make some different plans throughout that growing season to help us with that. Whether that's some sort of a rescue treatment with a fungicide, whether that's segregating our corn in different bins, whether that's maybe looking forward to buying some different feed for our livestock, it'll give us some different options down the road. And I think that's really important. Again, this is something that's under development right now. So hopefully in a few years, we're going to be able to come up with a model where we can just look at weather data and be able to predict how much vomitoxin is going to be in our corn.